Okay, so now we're going to go ahead and do example 2, essentially doing the exact same thing as example 1. So this is to reinforce the concept we've just learned. The function here that we're dealing with is g of x equals to negative log 2x plus 2 minus 5. Just so you know, when there's just a log by itself without the base specified, we have to assume that the base is 10, because that is our common base for logarithmic function. So for the first part, it says describe the transformation that must be applied to y equals to log 10x to obtain the graph of g of x. So I'm going to go ahead and just write down the function g of x. So that's g of x equals to negative log 10 2x plus 2 minus 5. And as you can see here, I can factor out the 2. So that's what I'm going to do before I go ahead and describe my parameters. So I'm going to factor the 2 out. I get x plus 1 minus 5. Now going ahead and describing what each one of those parameters mean. The negative here is a reflection in the x-axis. So reflection in x-axis. The 2 here is going to be my horizontal compression by a factor of a half. So it's a horizontal compression by a factor of 1/2. The 1 here is going to be my horizontal shift 1 unit towards the right hand side because my d value is a negative 1. And then the negative 5 is going to be a vertical shift 5 units down. Okay, so that is basically part A. And as I said to you earlier, whenever I indicate what my horizontal shifts are, I like to write down my vertical asymptote so I keep in mind what it is. So since d value here is equal to negative 1, my vertical asymptote is going to be x equals to negative 1. Okay, so part B says sketch the graph of g of x. When I'm sketching, I'm going to be keeping in mind what my key points are. So x, y, and y here is log base 10x, which is going to be 0 and 1. Those are my key points. And then writing down what my transformed points are going to be. And when I'm writing down the transformed points, I like to keep in mind what affects my x values and what affects my y values. The outside parameters, which is the a and the c value, affects my y values here. So it's going to be a negative y minus 5. And the inside parameters affect my x values. So here I'm going to take x and divide them by 2 because it's a horizontal compression by a factor of 2. And I'm also moving my function 1 unit towards the left-hand side, so it's going to be a negative 1. Okay, now coming back to what the x values have to be for my key points on the base graph, this is going to be, I'm just going to write this down first, x equals to 10 to the power of y, keeping that in mind. So 10 to the power of 0 is going to be my x value, which is equal to 1, and 10 to the power of 1 is going to be 10. That's going to give me a y value of 1. Transforming that, so 1 divided by 2 is going to be a half, minus 1 is negative a half, so I'm just going to write that as negative 0.5 because I can convert that to a decimal, and I would need to know a decimal when I'm graphing. And 0 times negative 1, which is 0, minus 5 is negative 5. Doing the exact same thing with the second point. 10 divided by 2 is 5, minus 1 is 4. I have 1 times a negative 1 minus 5 is a negative 6. Okay, so I got myself my key points, keeping in mind my vertical asymptote is x equals to negative 1. I'm going to go ahead and graph this function out. When I'm graphing this, I like to look at what's my minimum and my maximum x values and my minimum and maximum y values. So in this case, I have a minimum value of negative 0.5, so I'm going to have a negative 1 there, and a maximum of 4. So 1, 2, 3, 4. And my y values go from negative 5 to negative 6, so 1, 2, 3, 4, 5, and 6. It's negative 5, negative 6. I'm going to start off with writing down what my vertical asymptote is, which is x equals to negative 1. So that's my vertical asymptote. I'm just graphing my key points, negative 0.5 and negative 5. So negative 0.5 and negative 5 will be right there. And I have 4 and negative 6. So 4 and negative 6 right there. And now I'm going to go ahead and just sketch this, keeping in mind that I have my vertical asymptote that I need to make this function approach to, and just extending this further down. And that's my x-axis, that's my y-axis, and I'm just going to label my graph. G of x equals to negative log 10 2x plus 2 minus 5. Alright, so that basically is for part B. And part C basically asks, state the equation of the vertical asymptote, and I've done that several times. I'm just going to go ahead and write it again formally. So x equals to negative 1 is the equation of my vertical asymptote. State the domain and range. When I'm trying to figure out the domain, I span my x-axis, and I notice that my function here must be greater than negative 1. It's not equal to negative 1 because that's where my function approaches but never actually touches. So my domain is going to be in set notation, so x such that x must be greater than negative 1, and x is an element of real numbers. And my range is going to be, spans all of my y points, so I have absolutely no restrictions on the y-axis. So it's going to be y such that y is an element of all real numbers. Okay, that's great. And just summing it all up with part E, it says if 102 is a point on the base graph, state the coordinates of the transform point on g of x. So I'm going to refer to part B there along with my table of values. So I have 102. I'm just going to use a different color there so we don't get confused. So I have 102 as my point. So I'm just transforming that. So 100 divided by 2 is 50, minus 1 is 49. And I have 2 times negative 1 is negative 2, minus 5 is negative 7. So my new transform point, I'm just going to do part E there, is going to be 49 and negative 7. Alright, and that concludes example 2. Thank you.